Okay, cool. So I have some feedback in the chat. I have a screen to share. Say something. Oh, that okay, that did it. Okay, cool. So what we were about to do is create a cell phone. So I thought a little bit. I showed a little bit on the different M5 stacks. So M5STACK is a product from China, and it is 5 by 5 centimeters. It contains an ESP32. So this one here, maybe I can focus a little bit. One. And you have them in two models. So there's you cannot see the difference because there's a sticker on top, but there's one M5STACK W Room and the other one is M5STACK W Rover. So those are different models. So this is like the top yeah, the top part. So it contains a microcontroller in here. There's a slot for a micro SD card. There's an antenna, a USB-C connector, a power button, a Grove connector, and Grove is, open the box, a way to use simple cables to connect different devices to each other. You can even connect two M5 stacks to each other to play a card game, for instance. So if you have like the M5 stack Go, which is like default, it comes with like two extra ports. So there's one Grove connector by default, but if you have the Go version, you have like two extra connectors. There's a battery in here, so 370 milliamps, and there's two LED bars, one on this side and one on this side, and by default it's only this, but this is a special version and it has like RFID inside. So this is RFID 13.56 megahertz. So this will allow me to right, join this one. Can I turn it on? This is something else. So what is this one? So this contains an 522. So what I created here is using a piece of Arduino code and card cloner in 5 by 5 by 2 centimeters. So you can put this in your pocket and just clone a card. So I have a couple of cards. So this is actually a Juris school card, and he has multiple. So this is his other school card. And if I scan this one, it will tell me the ID of the card. So let me. Please scan the card. And it will tell me 006A7405. So if I scan this card, nothing will happen. So what is the reason that this card isn't scanning? Anyone, any suggestions? trying to make it interactive here. So why is this card scanning on NFC and the other one is not? And note there's a barcode here. RFID blocker, wrong frequency. Yeah, could both. So it could be like it's blocked. It could be like 125 kilohertz, or there's a lot of different frequencies. But we can actually figure it out by using a light. So this is a very strong light. So let's different chipset. So what I'm doing now is I'm using the card that worked. So am I able to show what is happening? So in the inside of the card, you can actually see the chip. So there's wires here and around and around and around. And somehow there's wires here as well. So this is where the chip is. So this is a card containing a chip. Now get the other one. This does not contain anything else. It's just a plastic card, and they were using a barcode at the time. So with barcode scanners and just plastic cards, they used to have their system, and then they upgraded to RFID cards. So one has a chip and the other one has not. So that's the difference. So I have another card. So this is like an old public transport card. You always have to look very aggressive somehow if you are on official documents. So am I able to read this code? So yeah, I'm able to read it. So this states (914FC12E), and if I get this one, it states 006A7 405. So on eBay, AliExpress, Banggood, Dealextreme, you can buy these cards, and you have them in different forms. So this is like a something that you can put on your keychain, but there's also stickers, there's cards, there's even leather that has chips inside, and they sell those with normal cards. So you have like a preset ID on the card. But there's also ones where you can overwrite the serial number of the device. And the serial number in UID is set in sector 0 of the card. So there's a couple of sectors depending on the size of the card, but sector 0 contains the serial number of the card. And on a normal card, that one is set. And on a UID writable card or sector 0 writable card or Chinese clone cards, there's different names for them. And if you go on a journey, you will find all the different names. You can buy these cards, and depending on how many you will buy, they will be cheaper or more expensive. What you can do with this, so this is like a gadget that I built for red teamers. So I can scan this card and copy it here, and this is like the gesture that I need to do. So this is scanning a card. Come on. scanning a card and cloning the card. So now this card is 405 and this card is 405 as well. So if I'm using the other card, so this one should still be 405, it is. So scanning this one. 12E, and now you see this card is 12E. So it's just a matter of a few seconds to clone a card using this ecosystem, using this special RFID bottom of the M5 stack. So I can tell you a bit on how I created this. So let me see if I can open the sketch that I made for it. There is like this Dutch audio stream, and I took open, let me see, open with more apps using Notepad. Fine. So let me switch to another view. So this is my screen view. So this is the piece of code that I created or reused. It's, I think I was looking at the RC522 on Arduino. So in C, if you're familiar with C, there's like a couple of things that you need to know. So your program can consist of more programs, like different libraries. So on the top of your program, you can include special files like here we are including wire.h, and wire.h is a library that is being used for SPI communication. So it allows you to communicate with the reader, with the card reader. And there's MFRC 522. So this is for the protocol itself. So the wire.h is to be able to talk in SPI, while MRF 522 is especially for the card reader. So you can have multiple devices, like the screen might be an I2C device, or the LEDs on the side might be an one wire device. So it's like different protocols that allow you to communicate. And the last one is M5STACK, and M5STACK is the library that's being used for this entire ecosystem. So that allows you to address the buttons or the screen or all the other stuff. So these are things that you need to add to your program to make it work in this ecosystem. So this is the first line of code, and this states give me a new program, a new instance of MFRC522, and there's a parameter OX28, and OX28 is the I2C serial number. So for people that are older, we used to have like things as SCSI, where you have like multiple disks connected to just one wire, but you need to set like a special switch, like my first drive is 1, my second drive is 2, my third drive is 5. So you have like different devices. And the same goes for I2C. So I2C allows you to have 128 different devices that you can connect to a chain. Are you still able to hear me? Because I see not much interaction. If so, it's okay. But if I'm just showing stuff and you're not able to hear me, that will be awkward. Anyone? Cool. Okay, still working. This is like the. Can we get the code? Yeah, you can get the code. I should put the code on Git, but I can share this code. So then there's the next one. This is the old UID byte, and I store 10 bytes of code for the UID, max 10 bytes of code. There's a buffer, a block. Oh, this is waarde, which means value in Dutch. So I need to up a bit. And these are factory keys. So this is just a number of keys. So inside a Mifare card, there's the first sector is readable, and the next sectors will be encrypted using a special code. And these codes are 6 bytes long. So if these are properly, yeah, sorry for the delay. That must be because of OBS. So for the 6 bytes, these encrypt the data that is on that specific sector. So if you have a Mifare classic card that has a piece of data and this is the code, it can be from 0 to FFFFFFFFFF. So this will take you a long time to crack it. However, developers are lazy and they use like default stuff. So if this code is still 0, you will be able to read all the data that is in the sectors. But sometimes people say, well, what if we create like a code that's 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C? Would that work? Yeah, it would absolutely work. However, if people find out that that is the code somehow to reverse engineering or whatever, you will be able to reverse this entire process. So what you see is like these are 6 lines or 7 lines or of code. But if you search the web for more codes, I think you can come up with 1,000 codes. So instead of having to test all the different codes, you can just test the 1,000 most used ones. And maybe the person that created the card or that crypted card, yeah, use one of those codes, and you're able to um, check it somehow. So next up, so this will initialize the I2C communication. The M5 begin will start the M5 ecosystem, like for the screen, for instance. So this will initialize the screen. This will stop the speaker from buzzing. So there was like a humming sound if you do not send a speaker end to it. This will initialize the 522, and this will show the reader details. And show reader details is actually a function that is mentioned later on. So this is just to make it more modular. So the first thing that it does is it clears the screen and then shows a please scan card. So if you look at the uh, like this, go back to microscope view, you will see please scan a card. So this is like the thing that it used to start with. Okay, Then for C code, for Arduino code, there's two important functions. The one is the setup. The setup has been run whenever the device got powered, and the loop is looped constantly. So the setup will like initialize variables, set like the defaults to it, while the loop will constantly loop. This will loop forever. So that you have to keep in mind. So it first initialize everything and shows a please scan a card. Then it tries to look for a different card. And how does it do that? It uses two functions of the MRF C522. First one is new card present? So somehow it noticed that there's a card present, and pick read card serial. So am I able to read the serial number of the card itself? And it will delay for 50 seconds and then return. So if this works, if this is true, so if there's no card present and you're not able to read the serial, that's the exclamation mark here. Oh, sorry, yeah, good one. Need to switch to the code. Thank you. That's why being interactive helps. Okay, screen view. So I'm setting the fill screen to black. So I'm setting my cursor to 00. I'm setting my text color to yellow, the size to 2, and I'm setting the color to 00 again, and then I press show source card. Then I'm reading the type of the card using this function. And then I'm doing a memory copy of the UID, and I'm putting the bytes, so the bytes that it obtains from the card. So what are the what's the current serial number of the card, and take the size of it and put it in inside this one. And here you will see show the UID, and this is the serial number. So it will be printed in hex, so you will be able to read it. So let's scan the card. And now switch back to the microscope. So scan the card. So you see source card, UID, and hex code. Okay, back to the screen view. Then it will show the size of the card. It will show the type of the card. So these cards. So go back to the microscope. This is a Mifare card, so Mifare 4K, and I'm taking this one. This is Mifare 1K, so this 4,000 characters, so 1,000 characters. But there's also other cards. I don't know if you're familiar with these ones. These are amiibos, and amiibos are cards that can be used for, like, for instance, Nintendo, to unlock special characters inside your game. And if I scan this one, it will tell me it's a Mifare Ultralight or oh, somehow I need to aim it where the antenna is. Here, or ultralight C, ultralight or ultralight C. So this is not something that I programmed. This is something that's already in the library. So that will tell me whether it's like a military grade card. It's like a Desfire, ultralight, or a classic, or whatever. So this is something that's in the library. Go back to screen mode. So this is the get type. This is like a CRC, I think, on the bottom. And whenever this is done, it waits for 3 seconds. So it's milliseconds, so you have to multiply it by 1,000, so 3,000. And then it asks for scan a destination card. So what I first do is I send the Unbreak sector command. Why do I use this one? Sometimes when you use a sector 0 writable card and you remove the card too fast, you will break the card. So you're not able to use that card anymore. And by sending like these special unbrick commands, it will like format the card and make it work again. So whatever the situation is, how fast you need to remove it, this will always work. So especially for situations where you need to clone it very fast, you don't need to, or you don't want to like break a card and go home, obtain a new one. So it asks you to scan a card and brick sector. I have to see where I am writing it. Oh, writing it in the Unbrick sector. I have to look at it here. Okay, so next one, this is for writing the data as hexadecimal, and it's like a trick to have a 0 if the number is smaller than 10. This one will show it in ASCII, and this one will show the details. So whenever the device boots, it will tell if the device is found, what the serial number is of the version of the device itself. So it's the 1 or 2, and it will check everything. I have to unbrick. Oh, the copy is inside the unbrick command. So this will show the source of the card, will scan the data, will wait for 3 seconds, and then will unbrick and write the command. So this is like a very simple card cloner for Mifare, and not for entire Mifare cards. So you're not able to copy like public transport cards or whatever. This is just for cloning the UID of a card, which is in a lot of cases enough to open a door or get access somehow. So that's for this one. And now go to another thing. So this is the echo. So let's go to the microscope view. So this is one of the newer M5STACK devices, and I have gotten this one for free from M5 to take a look at it. So they sponsored me with this device. And what I need to do is I need to connect it to a USB-C cable. So where's my USB-C? And now you will see some LEDs here. And what I need to do is I first need to go to the device manager, which is on my other screen, and I will open it. here. Put this one baby monitor. Yeah, maybe. But it are you able? Yeah, it's hardly. So this states that it's COM port 7. So if I remove the cable, it will go away. So this is to test if the COM port that is connected to this device, the UART connection that is there, is actually working. So COM port 7. So I'm opening PuTTY as a serial communication, and you can use a serial on a Macintosh, or you can use Minicom or a screen on a Unix machine. So COM port 7. Serial. I do this on my other screen. So if it is set up, I will switch it to the other one. COM port 7. Open. So here it is. So go to change settings. Go to appearance. Go to 48. Apply. And go here. Can I make it large? Yeah. So what I'm doing now is I'm putting it in front of my mouth, and I'm going to say computer. And it's recognized the word computer. So I'm going to say, just tell me what I have to say. And I will try to see if the speech recognition that is inside this device is working. Car. Warranties. Who is Siri? Okay, some people have issues with quality. Joseph has not. Cyber. Book. Yesterday I tried I void warranties, and it had quite some issues with that. So let's try it again. I void warranties. Yeah. I void warranties. Void warranties. So you see that it works quite well. It's not 100% Yillis. Is that a question, or do I have to say it like Yillis? Wonder what it makes of it. Jealous, yeah, must be. Giles. Gels, yeah. So different language than English might be hard, but I've seen ASR, automatic speech recognition, that required quite some expensive licenses, and was working way less than this product, which is, yeah, very cheap. And it allows you to record. It allows you to play. It allows you to transmit infrared signals, so you're able to turn on your television, for instance. So there's a lot of cool stuff that you can do. And on the back, it is connected to the internet. Yeah, it must be cloud-based. It must be cloud-based. So I have to. Uh, I don't know, but let's just open a window and do a live. Okay. M5 stack. While we're at it. So the core. So this is the core, like this one. And yeah, packet inspection time. That would be fun. Like looking in between what it is actually doing. And I just upload the firmware, did not look at it. So this is just a simple test, but looking at the lower layers using Wireshark must be fun. So if you're using this one, it has like 505 RGB LEDs, so you're able to do stuff. And the stream that I did last week was about creating dice, like doing random dice throws. This is one, so this 895. This is one that only has one light, so 595. And let me see if the voice is here somewhere. Atom. Where's the Echo? 995. So it's very cheap, and like there's a lot of cool sensors. So if you look at the modules, these are the bases. So the Plus has like a special wheel on the top that can move up and down, and you can compress it. There's a LoRaWAN module, and depending on the region that you're in, you're gonna need an 868 megahertz or 433 megahertz. Um, there's an NB-IoT, which is like a different kind of a LoRa. They have the SIM 800, and we're going to use that later. A GSM module 485, a motor, Lego stuff. So like, there's a lot of stuff, and this is the same one. So this is also the RC522, but this one is using the phases shield. So I have that one as well. Let me get it. So, so this is a phases shield using a RC522, and we were using this one, correct? This one, I think. Let's turn on the power. So now it's working with the bottom plate, but I can move this one from the bottom. So I now separated them both, and I'm moving this one on top of this one. It might need some power. I hope it used the same. Okay. Ah, it does work. So can I scan a card? and not that one. Need the other one, and it will scan it too. So, but this is like the size of a Game Boy. Yeah, there are daisy chain limitations. So yeah, as you can see here on the bottom, let's go to microscope view. I don't know if you can really see it. Maybe I can put this one down a little bit. So you will see there's like different pins. You're welcome, Jan. 23, 29, 18, 3, 3.3 volt, ground, 5 volt, 34. So as you're using I2C, I2C is just a bus. So let me get my other screen, screen view. I2C. So this is what happens. You have a data channel and you have a clock. And the master initiates the communication with the slaves and maybe with other masters. So by having, do I see a small section? Yeah, you can actually, and they. This is like something that I was working on myself. Switch back to the microscope. So these are just proto boards to 54, so it's like the same as a breadboard. So you can solder your own stuff. So this is a CC1101, and the idea behind this one is have like a software-defined radio that's sub-gigahertz receive and transmit. So you're able to open garage doors with this one. But I saw some tweets that they might build something themselves. So this is just me using a proto board to make this work, but maybe they will come up with this themselves. Um, so if you have like I2C, you will be able to connect multiple devices. So here you see like this is a what is it? 8266 ESP with a screen and with a 10 degrees of freedom sensor. And like this one has 20 and this one has 40, so that they're able to communicate over the same lines. So if you're stacking all I2C modules, that's not a problem. But if you're like stacking different devices that expect SPI, for instance, on certain pins, on a pin that you configure to be I2C, it will not work. But there is, if you look at the documentation on M5STACK, they will say this shield is using I2C, this one is using SPI, this one is using analog pins. So you can use this or that in combination. But the same thing goes for Arduino Uno shields. So if you stack those, you need to be careful. I think you have more freedom stacking Arduino boards than M5 stack boards. But yeah, be careful. Okay, so that's for that one. So put this one back together. So it's always need to have like a small card cloner. Could also always be convenient. And be ethical here, people. Be ethical. Need to say that. So there's another thing. So you are able to, this is like, show it on the other screen. Come on, microscope view. So this is like a magnetic holder. So you can screw this against the wall and just connect it to a USB-C. So you will be able to have this conveniently charged and take it whenever you need it to go. And another one could be this, and this is like a fingerprint. So it allows you to scan and enroll your finger on the device, and you will be able to disable an alarm, for instance, or turn on the fast Wi-Fi. You can figure it out. So it allows you, these devices allow you to interact with Wi-Fi, with Bluetooth, yeah, with all sorts of communication stuff. Okay, telephone. I have. Where would you recommend a fellow European to order it from? I know in Eindhoven. So let me get a screen. tinytronics.nl. I don't know if they ship like European wide, but this is at least for the Netherlands. They have some delays, and I saw that they were so search for M5. Selling a lot of these, so Atom Light, Atom Matrix. Do they sell the? Yeah, it's actually reasonable prices if you bear shipping in mind. So if you want to get it fast, this would be my shop of choice. Maybe they even have, let me see, M5STACK store, local store. I don't know if they somehow show you where to buy their products, where to buy AliExpress. Yeah, these are just people that created the stock and are selling it themselves. But yeah, I think you might have to buy some too. What, Joseph? What do I need to? You need to buy some, or I need to buy some? I think I have quite some already. Okay, we were about to create a cell phone. So I have two phones here. One is a Nokia 6600 and the other one is a Nokia 3310. So let's get a SIM card. Must be making a mess already. Yeah, this is a converter piece. So adding this together, inserting this. Where's my battery? Must be battery here somewhere. Yeah. Okay, works. Let's turn it on. Make this a little bit higher so you can see both of the screens. So I charge them the entire day. While it's booting. Oh, I heard my audio is very low. Oh, odd. Okay. Okay, this one is started. Type some time and date, whatever. And I even created this epic picture of my keyboard. So, so I have two telephone numbers. So let's first see and do a basic test. So I'm using burner phone numbers. So one is one, I don't know. Okay, dial. So this is the other one. So both numbers are working. Let's try it the other way around. So okay, so both numbers work. So this is like the first test that you do. See that your numbers are okay. So what I need to do now is mark them somehow. So this one, okay, let me first get a marker to mark my sims. CD marker, that should work. Okay. Okay, so this one, I have a, let me see. So this one is the 19. So 19. And then this one must be the 8, 6. Okay. And look at this funny cow. Let me get a sticker as well, because I cannot look at the inside of the. Getting one of those fancy Dymo stickers. Yep. Because I know if I do not do this part, I will mess up. Definitely. So add a sticker, and this is 19. So this is 5. Okay. So number is on the back of the phone. So I have worked on this for quite some time. And if you look at this device, I thought, well, the connectors are on the bottom, and it should go in like this. And it did. However, it did not work. But after a day of testing all kinds of AT commands, it turned out it needed to be in like this. So the other way around. So the notch off needs to be on the outside and not on the inside. So there's two devices that I have here. And I need to zoom in a little bit. So where are you? So looking here, maybe even a little bit lower. So this states microphone enable mic-en, and those are two pins. So let me get something to point at it. So these two pins are not connected. Yeah, there's an engraving to show the orientation, but it is not very, yeah, it is. Then I did not look careful enough. Very faint, that's correct. So these are not connected. So I figured out that the device was not working. So this is the module. It's a SIM 800L, and it has a microphone. So this is where the microphone is connected on the outside, but there's no speaker on this module. So what I did is they added a 3.5mm jack to be able to put in earplugs to listen to it. But if you insert this, it will still use this microphone. So by soldering this wire, you disable this microphone and you enable the microphone that's in the wire. So if you're using, like for instance, the Apple earpads or whatever, like this stuff, there's a microphone inside the cable. So we need to connect the jumper. And fortunately, I already did. So these two, maybe I can add or shed some light. So these two connectors, two aisles are connected. So use a little bit of solder on the back. Should have cleaned it a little bit, but doesn't matter. And this allowed me to use the cable to do the communication. So then if this one is connected, I need to get the card from this device to this one. Okay. There's like a click to it. So microphone enabled. There's a GSM antenna, but there's also a connector here to connect an external antenna. So as this is inside the entire stack of modules, it is plastic, however, and there's like some opening in the circuit board to be able to transmit and receive. But if you want to have an external antenna, that's also possible. So you can add like the tiny MCX to whatever on the outside and attach a GSM antenna to the device. So looking at this, where's my Arduino? Arduino. We need to connect this device to an M5 stack. Okay. So connected it. So there's now like a blue part under the gray part. And we go to M5STACK to see how this module works, because we don't know. I don't know. So product. So this is a module, and this is the GSM module, and there's also an LTE module for 4G, by the way. But 2G still works. So with voice, speaker via G25. This is a different module. Where's the other one? SIM 800. This is the one. Yeah, the red one. So there's an RX, a TX, and a reset. A microphone, head plug, antenna, SIM card, and that's basically it. So this is how, oh, sorry, you're not able to see what I'm doing here. So let's move to the screen view. Zoom in a little bit. So this is the module, SIM 800. It has like TX, RX, and reset. And it's a 2G network that features 3.5mm microphone. Works on 3.8 volt. Okay. So we need to create a program. Sample code for sending SMS, AT, transparent network test. Okay. What is this? So this is already a piece of code that we can just copy from their website. So this is the Arduino software. So let's start from the beginning, because this is not installed by default. So put it back on Arduino Uno. Now we go to board, board manager, ESP, and we're going to remove this one. Okay. And what we need to do to make the M5 stack or the ESP32 work on a Arduino IDE. So Arduino, tutorial. So you need to download the Arduino, and what you need to do is add this specific line, which is on the M5 stack side, to your Arduino IDE. So going to the Arduino again, and if you go to File, Preferences, there's an additional board member manager URL. So if I remove this one, which is by default, and I go to boards, board manager, and I search for ESP32, I do not find any boards. So to make this work, we need to add this specific line, which adds a special repository to the Arduino. And if we now go to the board manager and we search for ESP32, we see the expressive systems being part of it. And it shows all the different numbers. So if you have like code that's specifically for a version number, you can install the oldest one. But like for M5STACK, you can always install the latest. So we're installing 104. So install. And if you have questions, remarks, just shout them out in the chat. So it's installing all the tools, boards, but this is just the software that is used for the ESP32. So this will not only do the ESP, the M5 stack, it will do all the different ESPs. So installation almost completed. This is closed. So if I go to the board manager, it did not only install M5STACK, which is here. So this M5STACK Core, M5STACK Fire, M5STICK, but also the Olimax. Yeah, we're adding a GSM to M5, correct. The Node MCU, Adafruit Feather, so there's like all different kinds. So you added all these boards to the Arduino IDE to use. So if we're using the core, which is the gray one, ESP is like a model number of an expressive chip. So you have the ESP8266, which is a smaller version, and you have the ESP32 W room, which is the faster version, the basic one, and there's an ESP32W rover, which is the faster version, and there was some vulnerability found in older versions of the ESP, so there's a newer version now as well that mitigates that specific issue. So ESP is like when you have a Volkswagen Golf. A Golf is ESP, and expressive is Volkswagen. So now we only set up the software to program the chip itself, but M5STACK is not simply a chip. It comes with a micro SD card. It comes with a audio, with LEDs, with LCD, with all different kind of things, buttons, maybe a 10 degrees of freedom sensor. So you need to install that as well. So one part you install using the board manager. So we are using the gray version of the Arduino, which is the not the Arduino, of the ESP, which is the core. So I'm selecting M5STACK Core ESP32. So selecting that one. And I need to go to libraries. So include library. And if I go to manage libraries, I need to install M5STACK as well. And this will show up a lot of libraries. So these are libraries that are built by M5STACK themselves, but those are also built by people that created additions to their libraries. So you need to see which one is required for your project. So if you look here, so M5STACK, just plain M5STACK without anything else, is by M5STACK. So this is made by the vendor itself. library for M5STACK core development kit. See more information, http / M5STACK. So this is what we need to install. So install latest version 030. So installing. Now you see it is installed, but there's also like an SD updater. M5 Easy made by Rob Gongrijp is a very cool menu system that you can use. Like you only have 3 buttons, but what if you can make like a Total Commander or Norton Commander out of this M5 stack? There's stuff for the Atom. There's graphics stuff. Yeah, all kind of uh, projects that help expand the functionality of M5STACK. So we installed Arduino, we installed the board for the ESP32, and we installed the library for M5STACK. So those are the 3 things that you need to install if you're not using the UI flow that I talked about last week. So, okay, this is done. So now we have a screen, and it always starts with a setup, which is only started once, and a loop, which is started in a loop. So this is where you do the initialization, this is where you run your program. So now we're going to flash the software on here to be able to do the test. And if we go to example, you see all the stuff that is in here. And this, it's hard to read as small letters, but I will tell you what it is. Arduino over the air, Bluetooth serial, domain name server, EEPROM, ESP32, asynchronous UDP, Azure IoT Arduino, BLE Arduino, ESP-M DNS, FFOT, HTTP client, HTTP update, NetBIOS, preference, SD card, simple BLE, SPI, FFS, ticker, update, web server, Wi-Fi client secure. So these are all functions that are default in the device. So if I go to ESP32, I see analog out, camera, chip ID, deep sleep, ESP now, a free real-time operating system, GPIO. So I can select all other stuff on here. Preferences, simple BLE. So this will already get you started. But since we're not using on a standard M5STACK, but we're using the Shield. We're using the software that they suggested us to use with this device. So let's go to SIM 800. So this is the factory test. SIM 800 factory test.ino. So go here, select raw. So this should do it. There's a loop and there's a setup here. So this should be an Arduino piece of software. So I'm copying this and I'm pasting it in this one. And what we now need to do is we need to flash this device. And we can do that over the serial cable. So if I insert this one, and I go to Device Manager. This is a trick that you really need to do. If you're running on Linux, it's probably something like def tty USB, and same for OS X. So what it states is there's a UART. It's by Silicon Labs CP210X, USB to UART, COM11. So if I remove the cable, it is gone. And if I put it back, I see it again. So I know that by removing the cable, I know that this COM port belongs to the um, M5 stack. So why do I need to know the COM port? Anyone a suggestion? For the code. What do I want to do with the code? Actually, sometimes you connect to the COM port for reading the code, the API key, or for configuring the port. But in this case, we need to tell the IDE which is a serial port to use to put the software on the M5 stack. So what I need to do is I go to Tools. There's the board that we already set up, the M5 Stack Core. This is the speed which we use to communicate the cable. So if you have like a crappy cable, you could down the speed a little bit. And it's 80 megahertz or 40 megahertz. There's a flash mode that you can use, like a quarter or doubles. You can select a certain partition scheme, and that's uh, what do you think is more important? Do you want over-the-air updates for newer versions of your software, or do you want to have like a piece of uh, um, a part of storage on the device itself, so like a file system on the device. So having the red M5 gives you both, while the gray one probably makes you decide whether you want one or the other. And do you want to debug the information? And this is the COM port. It already shows me that it's COM port 11, and it tells me that there's another device in my home, the Decennium badge, which I'm able to flash from the Arduino itself. So this is configured correctly. So what I'm going to do is I'm going to compile. So while compiling it, I need to tell it where to store it. So GSM factory test save. So it just saves the code, and now it's compiling. So it tells me compiling sketch, and there's like this green bar on the bottom that needs to be filled. It will take quite a bit longer compiling for ESP32 if you compare it like with an Arduino. There's more to do, but there's also more functionality in the device itself. So I did not look at the code. I actually never seen this code, so it will be a surprise for me as it is for you. So with a bit of luck, we are able to use AT commands to dial the other numbers, the other number. So the phone that I have next to it, the Nokia 3310. Aha, I had a mate here. To you. Maybe it requires fixes. Yeah, maybe. Let's see. It is actually possible, and I did not do that, to show verbose information while compiling. So you actually see what it does. Yeah, I still have Granat. Actually, we do still quite have a lot of Granat. I have 2 crates here, but I got mine from RefSpace in Den Haag. Oh, this looks very cool. Okay. If I only knew at that time. Okay, so let's turn the light off. Okay, and switch to the microscope view and zoom out a little bit. So this showed, so this is the factory test. The SIM card is okay. The signal quality is 15, which is quite high. There's a GPRS supported on this device, and there's support for USB serial and AT command pass-through. So this is already part of what we want to do. So am I able to read the bottom one? So I can, this is hard to read. Get IP and ping, and this is signal refresh. So can I get an IP? I actually can get an IP from the network. So this is Baidu. That's probably something that they put in inside the software. Let's see if I can. Yeah. Okay. So I was not expecting this to be returned from the provider itself. So let's go to screen view. Can I zoom in or out? So there's the Baidu part. So we have a device that is connected via serial to the computer, which states that it has good quality, is able to connect to the network, is able to retrieve an IP address, or connect to a website on the internet. And it allows serial communication. Huawei, not then. So let's go to serial monitor. So this is the serial monitor. So if I press send, what will happen? Nothing. Why will nothing happen? Because this is set to a certain baud rate. And if these baud rates do not match, you will not be able to communicate with the device. So since the UART communication is lacking a clock signal, you have to make sure that the baud rates align. So what I expect is that this will be 115200. Yeah, wrong baud rate, correct. So do a send again. AT. And we're in. Hacker voice, I'm in. So tell me, Joseph, what am I going to type? I heard that you spent quite some time looking at AT commands. Okay, let's try that. So not then states, not then states ATH0 and 3 pluses, which give an error. The 3 pluses is actually an interrupt to show that you need to stop the current communication and go to AT command. And the ATH0 will show ATH0 will show you the hang up. Now I need to scroll back to. Am I able to scroll back? Don't know. What was it that you said? DTMF. Yeah, you can do DTMF. So what I'm able to do, for instance, is I have the other phone here. So this is the other phone, the Nokia, and the Nokia had this phone number. So I needed the other one. So if I'm going to dial the other number, so 0682045519, and I'm pressing dial, then it will tell me ring, ring, 80. So I'm disconnecting it. So what it tells you is this is the caller ID. So it's plus 31 for the Netherlands, 6, and then this is the number that's calling the other number. Don't know what 145 is, but it shows me. Sorry? Yeah, Jure tells me that +1 is America. Am I able? Looking at two things at the same time. I'm wondering how you manage to keep up to date on your stream, not then, on all the previous tap and swipe left. Am I able to scroll back? No, leave it. Okay, so what I can do actually is I can dial again. So menu. PinePhone, nice. So it's actually not the phone list, but the last one. So I'm calling this one again. And you will see, let me clear my screen, clear output. And if I'm sending an ATA, which means answer phone, hello, 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 then I actually, hello, let me see if I somehow can show you, hello, hello, hello. This is apparently not working, so let's add a hello, hello. So if I put this here, hello, hello, hello. So this actually works. So we have a connection between the Nokia and the M5STACK. So I have a connection now. So I want to break this connection. Apply, type 3 pluses and ATH0, which means disconnect. And now the connection is terminated. So if I do nothing and I just got a phone call, I will see the caller ID, so I can show whomever is calling. Um, I can use ATA to answer the phone. I can use ATH0 to disconnect the phone. There's some other things that allow you to send text messages, that allow you to create a GPRS connection, to um, uh, make internet connections. Uh, hey, I got a call. Hello? Who's this? Who's this? A guy from the chat. Yeah. This is how I met, if not Pike. And I really, really like that. Sharing phone numbers on your screen is always a good idea. Yeah. Yeah. Thanks for calling in. Okay. Bye. Yeah. That was to be expected, absolutely, and that was what I was hoping for. This is always fun. Cool. Um, so this is what happens. Sending a text message, but I didn't want to waste. I think there's a 10 euros of value on the phone, so we can send a text message. So there's another phone next to it. So if you want to do proper OSINT and not share your whereabouts, you can give me the command using my phone numbers. So if you can tell me, I want send a text to the M5 phone. Yeah, that would reveal your number. Hey Jan, nice. Thanks for calling. Yeah, no, never mind. I'm not into doxing people. I'm not Krebs. So what else are we going to do? Are we going to send a text message from the M5 to the 3310? Maybe sending it to me via Twitter might be more convenient for me to share it, other than reading it very quickly on the Periscope. Where's my here? Is my Twitter. Okay. Hey, Victor. Lol about crafts, I think. Okay, Joseph, you had the idea of sending a text message. If this then that, yeah, absolutely, you could do an if this then that. You could actually the thing not then not then, but if not Pike, he created like a DTMF where he used the word time, which was 846 3. You could dial the number and use some magic code on there to switch something on or off. So you could dial into your home, your cell phone number to switch on your coffee machine, or to restart your Minecraft server, or do whatever you want. So you're only limited by your imagination. So you could do whatever you want. And if this then that, uh, suits this a lot. So that there's a lot of LoRaWAN, IoT module, cloud-based solutions, the text-to-speech, GSM, CAN bus. So you can even tell your car to use the windshield wiper, for instance, if you know what command to send over the CAN bus channel. So, Joseph, are you sending me a DM with the AT command to use in the program to send a text message to the other phone? As I am lazy enough to do it myself. Pipe SMS directly to Linux server logged in as a... That's always a good idea. curl piping bash. Please do that. It is 11 p.m. here. What I can do is, instead of going through all of these different ones, is use my original sketch. Let's see if I have it. Open. Take documents, Arduino old, M5STACK GSM. CMGS. Okay, let's do that. 80 plus GMCS. Maybe I did not read it well. 80 GMCS is not doing anything. It's giving me an error. So what I did is, and I'm taking a shortcut here, is I'm using the M5STACK Faces shield together with a calculator shield, this one. So adding this here. So now it's a calculator. It's compiling my sketch. Nice. People using burners all the time. Yeah. Love it. Yeah, that's the one. But that's all I could remember. Jan. Okay, this one is compiling. So as soon as it is done, I will put the these two parts on top of this one. So now I will have an interface to call the phone using the keyboard. Okay, resetting, done uploading. So I'm adding this one. And rebooting. So if you look here, let me give a wider view somehow. Will this work? Okay, so go to the microscope view, make it readable somehow. So this is my phone number. Oh, okay. Can I copy this? Yeah. Copy. Oh, let's keep that notepad. Okay. We use this as an addition to the current functionality. So what I did is, this is a calculator keyboard, so it has all the digits, but also like divided, multiply, minus, plus, equal, and some other buttons. So if I'm going to call this one, so that will be 0682045519 call. Oh, it's ringing. But I don't see it. That's odd. Okay. Okay. Hang up. Come on. Hang up. You can do it. Okay. Call again. Using my headphones. Incoming call. So the other one is calling. And now I need to answer. And if I look at my code. So answer. Answer phone. Oh, is this one. So I answer the phone. Oh, I was not in time. I need to be faster. Okay. Again. Operation not allowed. So hang up. Oh, hang up. Come on. Call. Answer. Yeah. And now I can hear myself over the phone. So this works. So now I can disconnect. So disconnect is set to equal sign. So pressing the equal sign. And now it's disconnected. So this is receiving a call. How about sending a call? So this one is 065. Are you able to? Yeah. 06589322386. And for dialing, what did I use for dialing? So this is dial number is a star. So now I'm dialing a number. So if I answer it, hello, hello, this will work. So if I look throughout the code to see how this works, I'll take you to the other screen. Maybe enlarge it somehow. Are you able to see it? Must be. Okay. So we're including M5STACK again. M5STACK is the library for the M5STACK. The keyboard that is in here, actually, if you look at the bottom of the keyboard, maybe I can zoom in here. Microscope, where are you? I think this is so cool. We gotta call our people. Nice. This is an Altmail. Come on. always need to have a certain angle. So Atmel Mega 328P, which is an Arduino Uno. So this is a keyboard matrix that has an Atmel 328. You missed the stickers. You did not get them yet, or I gladly send them to you. And thanks for joining, by the way. This keyboard matrix is being read by this device, and if you look at the bottom of this, there's actually pin connectors to flash the keyboard matrix, but this is run by an Arduino and it communicates over I2C. So the keys are communicated, the keys from this part are communicated over I2C to the ESP32. So there's actually an Arduino Uno inside an M5STACK faces. So if I go back to the code screen, you will see the keyboard communication is 8, hexadecimal and decimal. The interrupt that they use, so whenever you push a button, it needs to know that it needs to read it, is 5. The hardware serial module is using 16 and 17 for communication, RX and TX. I used a timeout from 10,000 milliseconds to make sure that it tries for a while for 10 seconds and then stops while sending a command. So this is actually sending the command. So a piece of code that's terminated by /r character return to communicate the information. So whenever I start, I initialize the M5, I initialize one wire, I set the keyboard interrupt to pull up. I set the pin mode for the request to send. And I set the request to send to high. The SIM module communicates over 9600 bauds. And the first command that I will send is 80 plus CME EE equals 0. And the false does show that you don't have to wait for it. So if it does not work, I don't care. Just go on. Set the text color to white on black. Print the date, set the screen on the background on black, show ready, and show the telephone number that the device is on. So this is hard coded, but I don't know if there's a way to retrieve the telephone number. I did retrieve a telephone number of a dormant SIM that I still had lying around, but it made me call a specific number, and the number was shown in the voicemail. So it was not an easy way to retrieve it digitally. So the dial string is empty. And this is a loop. I create a state machine for this. So while if the keyboard interrupt is low, this means that it reads the communication. Okay, thanks. Yeah, it will be recorded, and don't throw it away. So you will be able to read through it or skip to the part that you missed. Thanks for joining, by the way. Cool. While the wire is available, and wire available means if there's I2C communication, it will read the data from the device. And if the data is not equal to 0, then there's data. So if this data is 0 to 9, it's one of the numerical keys. If it's A, then it's the AC that has been pressed. So there's AC, M, percentage, plus, multiply, divided, minus, equals, plus, minus, and dot. Those are the buttons that are on this device, and it will show them in here. So whenever you get a signal that some button was pressed, you will do one of the things. And if you press a button that is not defined, it will show a hexadecimal signal. So if I'm going here, and let's go back to the microscope view. So I'm pressing, let's put the light off, off. Okay, so I'm pressing M, and this will say debug OX4D. So I can 4D, so 40, what's 40? 40 ASCII. Let me look at 4D. Oh. So 4D is an M. So actually the M is the character M as well. And if I press percent, it will be 25. So 25 in hex is percent. So if I press plus minus, it's 60, and 60 is less than. So if I press dot, it's 2E, and 2E is hexadecimal, come on, is dot. So we still have some features left. So I think it's cool to use the suggestion of Joseph to include sending an SMS. So let's do that. Okay. So go back to the code. So let's use the M for SMS. So I did not explain the parts of the state machine. So 1 to 9 will add the value to the string. AC is backspace, so it will remove a value from the string. Slash will answer the phone. Star will dial the phone number that is in memory. Dash will show the network, or minus. Plus will show the signal strength. Equal will show the hang up, and the default will be show the I2C information. Sorry for not switching the screens. Thank you for reminding me every time. Okay. Sorry, man. Okay, so again, 0 to 9 for the digits, A for the backspace, slash for answering the phone, star for dialing the phone number, dash for showing the network, plus for showing the network signal, equals for hang up, and the rest will show the digit that you pressed. So what commands did I use? This is like add a value to a string, remove the last character from the string, This is ATA for answer phone. This is ATDT and the number. So as ATD, I could also do ATDP for sending pulse information. AT plus COPS reminds me of do not call the COPS circuit board to switch lanes. And CSQ give me the signal of the quality of the signal, and ATH or ATH0 will disconnect the line. So let's add the text that we're going to send. So instead of doing the ATDT with the number, so this one, we want to send. So I'm adding this one, and I'm using the M for M equals send text message. So sending SMS. So this is the dial string, and the command that Joseph gave me was 80 plus C message equals and I see a quote, so I guess I need to add that one. I need to have the dial string, and that should include a carriage return. Plus carriage return, and let's do a hi there and an end quote. So this should be what we need to do. 80 plus C message equals quote dial string /r text message quote and an enter to end the command. Okay, let's recompile the software. Oh, it's message, not C message. Okay, thank you. So remove the message. Yeah, I think we need to recompile it again. But this is just a proof of concept, and I should put it on Git, but usually I want Git to reflect what the quality of my software is, and this is not something that I'm very proud of. It's something that I just easily hack together. So that prevents me from getting it to Git. So, but people said, well, if it's on Git, you can improve it, or can others? The letters are C message. Oh, sorry. CMGS. Okay. Yeah, that's exactly what you have sent. CMGS. C message. Okay. Good that you're still awake, Joseph. And thanks for joining the stream. Really appreciate it. Will be time that you come over here. Okay, done uploading. Okay, so this is my phone that I'm going to call. So I first need to type in the phone number. So that's 06 589 32386, And now I have to press M. So send message. Let's switch to microscope. Microscope. Invalid input type. Hi there. Okay. Yeah, you're right, Victor. You're right. But yeah, somehow I always think that next employers are looking throughout your code base and going to rant upon you. So what did I do wrong? 80 plus C MGS equals. Maybe I do not need to put in the extra quotes. So I'm going to remove the quotes and see what happens. Actually, we could just flash the something happened or not. Okay. We could flash like the factory test to see if we are able to do it manually before programming it in there. But yeah, we need to sacrifice little kittens to the demo gods. Did not do that. Okay, again, 06. Let's do 5, 8, 9, 3, 2, 3, 8, 6, M. Sending SMS. Error, invalid input value. Okay, I'm done with it. Putting a delay between the AT command and the message text. Okay. Nice one, Victor. Okay. Let's see. Send SMS AT command. ATC. Okay. Maybe it does need to be with the international. So carriage return. Yeah, carriage return, not carriage return line feed. Send SMS. What I found, numbers. Yeah, there might be the plus 32, but I do not have a plus 32, so we need to implement that as well. So there was a plus minus, so let's add that one. So we have the digits, which are here. So copy. And the digits were, what was it, less than. So it needs to be less than. So less than 4 plus in, yeah, I know. I need to put it back to screen mode. Screen mode. So less than will add dial string plus. Then I need to put the quotes back. So that's 80 slash quote And the quote is around first the quote and then character return. Okay, slash quote character return hi there. Okay, okay, try it again. Oh yeah, should have read it. Thanks, not then. Okay, bye Jan. Thanks for calling in. Done uploading. Okay, back to microscope. Microscope. Okay, so that's plus. Uh-oh. 60. What is 60? Six. This something. Bye. 60. 60. Oh. So this is 60, which means it's art. Copy. I could do it another way. So go to this one. Again. Code screen, sorry. Screen. Yeah, works. Cool. Okay, webcam. No, microscope. So plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. M for SMS. Invalid input value. Okay, I'm done with it. So we're going to use the other sketch. Factory default. Flash it. So here we are able to back to code screen, screen view. Okay, no SIM card. Signal refresh. SIM card, okay, okay. This works. Now I need to go to this COM11. Let's use PuTTY instead of the Arduino IDE. So come on. Putty. So that's serial COM11 115200. Open. Why not? This COM11, right? Yeah, COM11. So is there's already stuff open? There's already stuff open. That does not work. Putty. Serial COM11 115200. Yeah. Okay. Right mouse click, change settings, appearance, change 48. Okay. Apply. That's huge. Make it a little bit smaller. Okay. Right mouse click, change settings, default setting, save. So I don't have to do it every time. Okay. So what I need to do is AT CMSG. The phone number is 6 5 8 9 3 2 3 8 6. And the message on the next line. Oh, but here they use the quotes on the same one. So invalid input type. So if I remove this one, copy, AT plus, no, C, M, AT plus C, M, G, S equals plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. Enter, invalid input type. Doesn't have focus. Why? Okay. Okay. Quote. Quote. Plus CMS message. Plus. ATH0. Data, yeah, it's in quotes now. Okay, something happened. Okay, this is odd. Okay, this is funny. Okay, where's my screen? Microscope. So the message that I get is actually the AT command. Okay. So let's try it again. I think it might be the H. Which H? H. Control D. Is it Control D? Okay. Burning the message. Message 80. So if I'm sending this one, Control copy, Control D. Control Z. In the code screen, it is not. Okay. Read. E. Message. This. Read. Message. We're getting somewhere. So in the code screen, so this is actually what I'm pasting. Oh, I need to press a Control Z at the end. Okay. Enter. Control Z. Okay. Control Z. Let's try it without the press lezen. Let's just opties wissen. Okay. So plus 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 plus. Okay. Enter. And now I'm going to only do the AT-CMS. So enter, Control Z. Read message. So this is how it works. Okay, cool. So we figured that out. So go back to the GSM. So we need to send the AT plus CMGS, the number with a plus 32. Then there's an enter. Don't know if carriage return is enough. Yeah, might be. And instead of enter, it needs to be Control Z. Maybe carriage return line feed. Oh, sorry. I need someone to switch the. Okay. So what I did is ATCM CMGS equals escape quote dialstream escape quote carriage return text Control Z and then carriage return line feed. So it's stage carriage return. Maybe this will work. Compile. So the trick was in the Control Z at the end. And if I had properly read the documentation, I would have seen it. Oh, access denied because I had a putty session open. So don't exclusively open COM ports because the IDE. Yeah, you have much more experience now. Then I really would like to pick your mind on it one time. What the best way is to share it? I think I'm already in focus, but yeah, the resolution is not well. What I've seen for like multiple streams is like people multiplexing it on Linux using Docker containers and. Don't know how you are concurrently sending out all the streams. Okay, so let's erase this one. No messages. So switch back to the telephone. Microscope view. So let's first use this one. So I'm pressing plus, and the phone number is 31658932386. And now I press M from SMS. Okay. Oh, nice. Yeah. It's like a subscription model, right? Restream. So this does not work. So if I'm sending hang up, maybe. So instead of carriage return, let's do a carriage return line feed. Yeah. Switch back to code. Carriage return line feed. Carriage return line feed. Okay. Okay, yeah. What, restream, Victor, or what I just did? Like adding the carriage return line feed instead of just carriage return. Done. Okay. Plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. Send SMS. Okay. Okay, let's first see if we are still able to call. So C plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6, and what was dial again? Dial is the star. Okay. Hmm. Important. Carriage return line feed. ASCII 26. Carriage return. Yeah, character 13. ATD. Why? ATC MGS equals quote del string quote return. Where's my insert? Return. Hi there. Control Z. Maybe do a couple Control Z's. Maybe do a number of pluses. Okay. Is Control C the same as Control Z? I expect so, but assumption is the mother of all fuck-ups, is what I've heard. Oh, you cannot compile if you do not connect the connector. Control Z Arduino string. Sending Control Z character in for my AT command. Oh, seems like someone looked at it before. Okay. The person came up with this solution. Plus, okay, 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6, M. Oh, it is in fact showing Z's instead of Control Z's. So, might be a good one. So, let's see what happens if we replace it with the /x version. Okay, done, done. Plus 3, 1. I could have automated this. 5, 8, 9, 3, 2, 3, 8, 6, M. Yeah, works. Oh, thanks, Crazy. This solved it. Read, read. Hi there. Hi there, Z. So there's probably still a control. Where's the Control Z then? Oh, ATH. Like old messages. Nice. Okay, so which means removing this one, and then I can remove this and this and this, and it does not need to be a line feed afterward, so this is enough. So carrots return, carrots return, carrots return, carrots return, carrots return, carrots return, carrots return. Okay, compile it again. Done uploading. So let's try it without the plus. So it's 06 5 8 9 3 2 3 8 6 M. No, it needs the plus 32. Okay, so that's plus 3 1 6 5 8 9 3 2 3 8 6 M. Again, maybe it was not initialized. 3 1 6 5 8 9 3 2 3 8 6. Send message. Error unknown. So why? Back to screen view. Get return. CMS error unknown. Okay, for the people that joined later, we're currently trying to make an M5 stack, which are these devices, to send an SMS message. So we added a GSM shield, like this one, to the device, and we're now figuring out how to send an SMS text message. Okay, again, plus 3 1 6 5 8. Oh, maybe first try the signal strength. Yeah, we have signal strength. Go back to microscope view. Hey Joseph. Okay, so we have a signal strength. So plus, oh, AC, plus 6 5 8 9 3 2 3 8 6. Star for dial. See if that works. That works. So telephone is working. So plus 3 1 6 5 8 9 3 2 3 8 6 M. And now it's CMS error unknown. Hi there. Enter slash. Carriage return. It states carriage return. Why does not it not work? ATCMGS equals escape quote dial string escape quote carriage return. Maybe do add a line feed. Carriage return line feed. Hey Jerry. So still 7 diehards in the stream. We're running for 4 hours now. Kudos for you. Free stickers if you will. Yeah, they are harder than they should be, especially the special commands. But you should like do this from a Linux terminal and do a octodump min-c to see what you're actually sending, to reproduce it. Like I'm now testing, compiling, running, all different things together. Maybe like the phone is not working yet. Okay. So plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6, M. Not working. So if I'm sending this carriage return line feed, carriage return. So this is a carriage return. Send this. So switch back to here. Copy and make a different command for the, so it has some pause in between. So hi there and end with a, where's my special character? Copy. Okay. So this command. Okay. Try it again. Writing, resetting. Okay. Test the signal strength. We have signal strength. Plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. SMS. Ah, that did it. Okay. So, Joseph, you were right. It was about pausing in between the commands. So, let me move this aside. So, bericht ontvangen, which means message received, read, hi there. So it was been fixed by breaking the AT command up into different parts. One for sending the dial string, and then you need to wait a little bit, and then sending the text message with a simple Control Z, and the Control R, meaning carriage return, was enough. So we fixed it, people. Thank you. So as we're crossing the 4 hours now, I suggest we call it a day. Don't know if you have anything else or anything to share. Please do so. And not then, thank you very much for joining the screen. Time for beer, absolutely. I have some Belgian beer here. Thanks for joining and thanks for restreaming it. Really value that. Yeah, I think, and thanks for sharing. You say not then. I'm not. Yeah, I'm sharing it in the video, but I should actually share this code in Git. What you did miss, Joseph, is that your comment that you need to split it, that you have need some time in between, was actually the solution to this problem. So by splitting the code up in two parts, so let's go to the code. Where are you? SMS. So I have one dial string containing telephone number, and the other one is the text. So by splitting it up in two separate commands, solved it. Thanks, Nodan. Have an amazing one.